Hello, good morning, everybody. Hope you are all well and staying back in your home. Today, I'm going to talk about variance and standard deviation. This is a sequel to my last talk where I have introduced the concept of variance. Variance, I said, is a measure of dispersion or scatteredness, and also it is a measure of volatility. Volatility is a term more frequently used in finance, means the same thing, fluctuation. So this is a non-negative number, and the value of this number indicates the amount of fluctuations in the data or in a probability distribution. I had raised a question that what is the meaning of variance equal to 0. I hope you have been able to figure out. So one hint is that if you have say three numbers x1, x2, x3. Now you take x1 minus and their mean is x bar, so x1 minus x bar square plus x2 minus x bar square plus x3 minus x bar square. So if all and you equate this to 0, then what would be the solution? So you can then generalize this idea, and the answer is simple, that if variance is equal to 0, then all the values of the random variables are equal, and in other words the random variable takes only one value with probability 1. Now that value need not be equal to 0. So this is important, that variance of x equal to 0 does not imply that x takes the value 0. It only implies that x takes one value with probability 1. That value may be 0, 1, 10, 100, whatever. Now let me ask another question, that suppose I tell you two things, that mean is 0 and variance is also 0. Then what can you say about the random variable? So then, of course, I leave it again as an exercise for you to verify that if mean and variance are both equal to 0, then it only means that the random variable is equal to 0 with probability 1. So these are two important points to be noted, that variance equal to 0 implies that the random variable is like a constant. However, the value of the constant we don't know. And but once you tell me the mean, then and variance equal to 0, then I know that the variance that the random variable is like a constant and taking the same value as the mean with probability 1. So this is something I wanted to asked you to verify in my last talk. And so today next I will give you another assignment, that suppose x is a random variable. Take a simple random variable. Then if you multiply a by a number, if you multiply the random variable x by a number, let us say 2, so 2i's x, and then add a number 1, so let us say 2i's x plus 1. So what will be the mean of 2i's x plus 1 and variance of 2i's x plus 1? So what will be the relation between the mean of 2i's x plus 1 and mean of x, and variance of 2i's x plus 1 and variance of x? This question can be generalized as follows, that suppose a random variable is taking values x1, x2, xk with probability p1, p2, pk. Then what is the variance of ax plus, let us say, c? A is a positive constant and c is any real number. So when you have a random variable x and you multiply by a and add c, this is called change of location and scale. Multiplying by a constant, positive constant a, is called change of scale, and adding a real number c is called change of location. So the question in general is what is the effect of change of origin and scale on mean and variance? So that is something I want you to find out. I am sure that if you have followed my first lecture on expectation of simple random variable, then the first part would be very straightforward, that is, you can easily tell me what is the expectation of ax plus c. And now once you have done that, then variance of ax plus c would be what? You have to take the difference ax plus c minus expectation of ax plus c, right? And then take its square and take the expectation. So that is the hints. Now I will tell you the answer so that you can verify. What you would get is that expectation of ax plus c is a times expectation of x plus c. This is supposedly you would have already realized by now from your exercises in expectation. and variance of ax plus c is equal to a square times variance of x plus, and but there is no effect of c. So we summarize this by saying that variance is independent of change of origin but not of scale. So if I go back to the previous question, what is the variance of 2x plus 1 in terms of variance of x, then the answer is it is 4 times the variance of x. And so this is what I wanted to share with this. And next I will talk about standard deviation. And standard deviation is another measure of volatility, or another measure of dispersion, or a measure of fluctuation in the data, and its definition is a positive square root of the variance. Now, why do we talk about the standard deviation? It is because the answer lies in that question, that what is the variance of ax plus c. So I'll talk about more about it in my next talk. As always, I'll keep this presentation short, but I hope you are following these lectures. But most importantly, stay safe. Bye.